My name is Darshini.
Hi, I'm Subi.
Okay, our project is on containerizing and deploying scalable application to Docker Swarm. So the phase one will be an introduction to containers, Docker, and Swarm. Okay, containers, it is a standardized unit of software where the software is packaged into standardized units enabled for development, shipment, and deployment. It is a piece of software in the form of an executable package which includes code, runtime, system tools, system libraries, settings that are needed to run it as a container image that is lightweight and standalone. It supports Linux, Windows-based applications, and containerized software runs the same on all the environments. The advantage of using a container is that it teams with different softwares that can be run on the same infrastructure without any quarrel. So basically, containers are lightweight, standard, and secure. Okay, Docker is a computer program which is like one of the world's leading software for containerization platform that supports operating system level virtualization termed as containerization. And Docker is developed by Docker, which forms a basis for Linux systems. Docker drives the container movement and provides the container platform for all the applications in hybrid cloud. In today's world, the business are facing a lot of challenges due to technological improvement and has to adapt to the changes as rapid as possible since they are constrained with the existing systems, applications, and infrastructure. Independence is enabled by Docker among applications, infrastructure, developers, and IT ops in order to bring out their capabilities to create a space for collaboration and innovation. Docker Swarm is a clustering and scheduling tool for Docker containers. With Swarm, IT administrators and developers can establish and manage a cluster of Docker nodes as a single virtual system. Swarm mode also exists natively for Docker Engine, the layer between the OS and container images. Docker Swarm uses the standard Docker application programming interface to interface with other tools such as Docker Mission. Swarm uses scheduling capabilities to ensure there are sufficient resources for distributed containers. Swarm assigns containers to underlying nodes and optimizes resources by automatically scheduling container worker loads to run on the most appropriate host. Okay, now we'll start with phase 2 on how to create a legacy application. Okay, the first step is to start by creating legacy PHP application. In this, for this, we have created a blank virtual machine. We have used the same golden image that we have used in the other labs. So it's a blank installation of CentOS with nothing installed. We have taken a blank virtual machine and installed web server, PHP, and database servers so that we can create a sample application that we will later containerize. In this slide, we are installing HTTPD, MariaDB, MariaDB Server, PHP, PHP Common, and all the PHP dependencies that are required for WordPress. We will be using WordPress as our sample PHP application. And this step shows that we are installing basic dependencies to run WordPress. In this slide, we can see that we have installed all our dependencies. Now we can start using Apache as web server, MySQL and MariaDB as database server, and the PHP dependencies are installed. Once the web server, database server, and PHP dependencies are installed, we enable start and enable the HTTP web server and database so that it is started up and we can start using it. In CentOS, we are using systemctl to start and enable the services. Once the web server, database server, and PHP dependencies are installed, enable start and enable the HTTP web server and database so that it is started up and we can start using it. In CentOS, we are using systemctl to start and enable the services. We are running MySQL secure installation. This is built-in package provided by MariaDB. The purpose of running this is that it just cleans out the whole installation and sets up root passwords, permissions, removes all the testing and other databases that are not required. Once this is secure, installation process finishes, we can start using the MySQL database. Since it's a new installation of MySQL or MariaDB, it will ask for root username and password, some security permissions that we will interactively give it, and then it will set up the MySQL server for us. In this slide here, all the permissions have been set and the process we have initiated has been completed. It removes all the testing and not required databases and sets the root password. It also asks us if we want to disable root login remotely, and which we will do because our application will be accessing locally and we don't need root login from remote computers. Now MySQL is ready to use. Now the web server and database server has been set up. We'll have to download the latest release of WordPress. WordPress will be used as a sample legacy application. In this process, we are building the legacy application first so that later we can containerize it, download WordPress and start installing it.
Now the download has been completed and we need to extract the tar. Once we extract the tar, we will get a folder called WordPress, and this contains the blank WordPress installation file. Now we will copy the WordPress installation file to our www.html in order to deploy the WordPress application. We are running a copy command to copy the contents of this WordPress folder to our www.html. Once the copy process is completed, we will set up some permissions such as changing the ownership to Apache so that it can read the files, and we will also set up some security permissions appropriate to the directory files. This is just a standard procedure recommended by WordPress. This is done at this stage so as to deploy the WordPress application properly. Once the application has been deployed to the file system properly, the next step is to set up the database. We have already set up the database, which is up and running. We will create a database so the WordPress can use it. We will log into MySQL console as a root user, where we will create a standard database called WordPress. All privileges are granted on this database called WordPress to a username called NSA713. And we will also set a complex password for this. Instead of using a root account for our WordPress application to connect, we will also give this a simple database and password for WordPress to connect to. WordPress comes with a standard configuration, but it is not named appropriately. It comes with the name WP config sample, and they leave it up to us to rename and set the proper variables for this configuration file. We will take this sample configuration file and add our own variables as per our environment. We are moving the WP config sample to WP config PHP. The WP config PHP is what WordPress expects for this configuration. This is the configuration WP config PHP, and as you can see, the variables are defined but are not set. The main configuration is the database setting, as WordPress needs a database to operate. We have just now created a database where we will give privilege to a user and assign it a password. So we will use the same settings where we will give a database a username and password so WordPress can connect to it. Now, as you can see, the database username and password that we have created earlier, we have put in the same values here so WordPress can use it. We also have to open the HTTP port, as this is the default installation of CentOS 7. By default, the firewall is enabled, so in order to access the port 80, we will have to open it using the firewall command line. So now the database and firewall ports are open. The database has been set up. WordPress files have been deployed. So now just by visiting the IP address of this temporary virtual machine, we can see the WordPress front installation page. Now we will start setting up our WordPress application. We are now setting up the WordPress application. All we are doing is setting the title page, the admin username and password. We are not creating any fancy application as we need only a standard application that uses a database and PHP as a front end. Once the admin username and password is set, WordPress installation has been completed and it takes us to the main dashboard of the WordPress admin panel. Here we will create new pages, add content, delete content, manage users. Since this is a simple application, we are going to rely on some standard default page that the WordPress comes with. Once the installation is complete, now if we visit the IP address of the temporary virtual machine, we will see the front of the WordPress application and we will also be able to see the title that we had set up earlier. The front page is being loaded from the database and this is enough of an application to be used as a sample application. This is nothing but a standard WordPress application with a default page and the title is NSA 713 Final Project.
My name is Rajai and here with me Mr. Anas. So, as Supi and Darshini explained how we created a standard PHP WordPress-based application, now we will show you how we will convert this application into containerized application. So, as they showed that we have copied the complete application to www.html to containerize this application, we also need the dump of the MySQL. So, what we are doing here in this terminal is that we stop the HTTP, the Apache service, so that there is no more changes on the WordPress application, and we will run MySQL dump on the WordPress database. This creates a WordPress SQL, which our WordPress application uses. So, basically, after creating this dump, the Word www.html is our complete application along with the WordPress file, and the database, this database is representing our application. All the changes, all the titles at the admin username and password that we created are included in this SQL dump. So wherever we deploy this SQL dump to our application, as Suvi and Darshini showed you, whatever changes that we apply to the WordPress default website will be there in the SQL dump. Web application has been setting to all the Word www.html. Now we have all the files and MySQL database done. The next thing is to create a Docker image. For that, first we will have to install a Docker. To install Docker recommended using the repository that they provide called the Docker CE repository, which is Docker Community Edition. We are not going to use Enterprise Edition because that is paid and not required for this demonstration in this project. We will enable the Docker CE repository here by using the yum config manager. Okay. Once the Docker Community Edition repository is enabled, we can install Docker as simple as running the command yum install docker c. This will install all the Docker dependencies and the community edition of the latest version. The latest stable version of Docker is 1.8.03, so we'll be using that. The task for us to approve that Docker yum repository GPG key, and we will say yes as we are testing the key, this key to be the genuine Docker key. So, as you can see, the yum command has finished and Docker along with all of its dependencies has been installed on this temporary virtual machine. the Docker has been installed, we will start the Docker engine using the systemctl command. So once our Docker engine is up and running, we need to test that Docker is running properly. The easiest way to do that is to deploy Hello World container application, which Docker provides by default. So just as simple as running Docker run Hello World, it will download the Hello World image, and this image is a very minimal few kilobytes. It's a very small size that has no other job than giving your welcome message for Docker. As you can see, how we run Docker, run Hello World, and it said that there was no image of Hello World found locally, so it downloaded from the library from Docker hub. It was downloaded completely. It was completed. It's running. It runs the container, and container gave this hello from Docker message and shows the Docker installation is fine and the container running properly, and this shows that the Docker engine is running proper and we can start using it. If we run a Docker image ls, we can actually see that the image that previously was not available, which is the hello message, and Docker that we had downloaded is now part of our repository. Once we run a container, the image is stored locally for future runs. So now if we do images ls, we can see that hello world image in fact is downloaded and stored in our local image repository, which is local. Furthermore, we can run Docker into info, and we can see all the details of our Docker engine. This output here is showing all the details of the Docker info command. We can see that it is using overlay 2 as the lowest drive, the version 18.0. It has one image not running, container no post, and one stop container. This stop containers is the one that we run for hello world. Appropriate system is CentOS 7, and all the details, all we can see in this screenshot. For our containerized of application, we need to create a startup script. This startup script is responsible for running our service, since we are running two services, i.e. a web server and database server on the container. It's good practice to have startup script. Normally CentOS comes with a supervisor daemon that can be used for such scenarios. But since our application is very simple and we just need a web server and database server running, we can simply create a bash script that starts above database and starts off our web service HTTP Apache server. Now, once upon startup script is being created, now we are in the HTML folder and we have over our WordPress files, we have our MySQL dump and we have our startup script. So basically, in this world, we have our complete environment ready now. We need to create a Docker file. A Docker file is a file that Docker engine uses to create or build an image. We will use CentOS 7 as our face image. As we can see in this first line up there, we set from CentOS 7, so we will use CentOS 7 as our first image. We will set up container, which is an optional step, but just for the sake of completion. We are setting the maintainer, then we will install all the dependencies that we installed that are required by WordPress system. These are the same steps that we are actually did to deploy our legacy application in a virtual machine. Instead of doing it on a virtual machine, we are doing it in Docker file, and basically when this Docker file runs, it will create our Docker application image. Now, you can see where we are installed the same YAM dependencies, where we are copying over our WordPress file to HTML, where in the 8th line we are copying the startup script that we created in the previous step to our HTML folder, and then we are changing the permission that we did earlier that Supi and Darshini showed for setting up the test practice for WordPress. Then we are running MySQL D command, and we are restoring the DOM that we created earlier. So this is our next step, and once the DOM has been restored, we will remove the restart.sh and Docker file because they are no longer required in the Word www HTML folder. We will expose port 80 and we will run the start.sh script that we created in the previous step. This will start the database and it will start the web server. So basically this Docker file is just doing all of these steps that are required to bootstrap our application from scratch. Once we give this to Docker engine, it will create a Docker container image for us. So once we have created the Docker file, we will run the Docker build command on our current directory. Docker build command will read the Docker file and it will do all the steps that we gave it and created the Docker image. We will use the -t tag and we will give our image a name. So for this image we are giving a name of our course NSA 713 project, and latest in the version that we can modify we can use any version tag, and work by default Docker use the latest tag. So we can use for now where can I use the latest tag. Our image name is NSSA 713 project with the version of tag of latest, and below this build command you can see that Docker is following all the steps that we mentioned in the Docker file. At 10th steps we will be performed and it will create a Docker image for us. Now once the Docker build process has complete, if we run image ls again, we will see that our new image is now ready. The size of the new created image is almost half gigabyte, 597 MB. As you can see, the CentOS image has also been downloaded in our repository. When Docker was building our image, we were using CentOS as our based image. So it downloaded the CentOS images as based image, as we talked before, and then the other steps, and then created the NSA 713 project image, which we named it like this. On the top of it, it show our NSA 713 project with the latest tag has been created and now ready to be deployed. Once the image is ready, we can now run our image in a container by simply running a Docker container run command. We are running Docker container run, and the name of our image and -p means detached mode. It means that we want to run the container in the background. Once we run this command, docker retains a unique ID of the docker, and our command prompt is giving back to us. And basically, docker starts running this image in the container. It is as simple as that. And since it's containered, the boot time is very small and takes hardly few seconds for this image to start up. If we do a Docker container LS, we can see that our NSA713 project image is running as a container, and the command is that start script that we gave it, and we know that we showed that the start sh script is nothing but starting two services, that MySQL service and the database web service in the background, and we can see that it is exposing port 80 is outside. So basically our image is up and running now in a container. This is a standalone container, and it's simply running exposing port 80. We can actually jump into the containers to see what processes are ready, and how we can also use jump into the container to do so debugging in case your application is not running. But for the sake of this demonstration, we will just jump into the container using docker exec commands, and we will give it contain a unique ID, and we will ask it to run give us a bash shell promote. And once we get the bash, set promote can run PSA work, and we can see that our Apache web server is running a couple of web Apache applications. Web service process is running, and MySQL database service is running. That's all our container traces, and they're running nothing more than the database service and web service. This is the reason it's so lightweight and it starts up so quickly. This is the magic of Docker and containers. Okay, here we can see the process in more details, and if we browse over container engine and sensors expose port 80, if we just browse and exercise using localhost, we can see the container is actually running up, and it is exactly the same thing as we can figure it. It's the same application that we containerized from our temporary virtual machine, and it's now running in a container with its own Apache web server and database. Once upon image is ready and tested, now we can upload this image to a registry. We can have our own private repository, and there are many other vendors that provide containers registers. For the sake of this demonstration, we will be using the Docker Hub as our image repository. How we will look to Docker Hub from the command line using Docker log command. Give it the username and password, and the Docker Hub will allow us to upload our image to the public repository. This is a public repository, and the purpose of using the public repository so that we can share this image with the rest of the class, so that they can expect us to test our containerized application. Anyone talked about it, I can test this application anytime they want. Okay. Once we have logged into Docker Hub using the Docker login command, we need to add the username of our account. In our image, that this is how Docker knows which account to upload the image to. So we have our NSA713 project image. We'll just add the username, so our tag will become user name, which is the username, or whatever the username is, stash, and a system of a project. So once the tag is there, we can simply run the docker push command, and it will upload the image to our account, which can then be accessed globally. Okay, we can see the Docker image has been pushed to the Docker hub, and now it can be accessed from anywhere, which is globally. Once the Docker image has been uploaded, it will give us that digest, which is a hash of our image. This hash is used to keep track of the image integrity, and it tells us the size. In our case, our image size totally is 1.7 GB. Yeah, we can go to Docker Hub using the same credential, and we can actually see that our image in fact is uploaded there, and it's available in our repository. We can check the details. Docker in fact tells us the details of our image. It tells us that what Docker command can be done to check latest image, and other details of how to deploy this image and stuff like that. Okay. Okay, how we can see the latest tag in the one that we used, and it's actually showing us that there is one tag latest available right now. That's that our Docker Hub, the image that was uploaded in the log house is fine and usable. We will delete our local repository image and try to redeploy it from the Docker Hub. To do that, we will delete all the images that we have. As we can see that we are deleting all the images that we have, and once we delete all the images, we will try to pull the image from the Docker Hub. We can see all the images have been deleted, and currently our repository is empty, as it was when we first installed Docker. We don't have any local image in our repository, and now we will try to download the repository, our image from the public repository, which is we uploaded to Docker Hub, to see if it works. Okay, download image. We simply have to pull the image, and the command for that is Docker image pull username and the image name. And as you can see here, we give it the same username and image name that we used to upload it, and it's not downloading our image from Docker Hub. It's now downloading our image from Docker Hub. The Docker image has been completely downloaded, and it's showing us the same digits hash should match with the original hash. This is to verify the integrity of the image. So our image has all the latest, all the layers of our image has been pulled, and we can deploy container based on this. To run the container based on this newly downloaded image, we just have to run the same run command docker container rum run and image name, and once we do that, we can see the Docker gives us the unique ID of this container and starts of the container for us using the image, this image. Once the image has been running, we can access it on port 80 to verify that our application in fact is fact running as good as it was when we uploaded the image to Docker Hub, or when we created the image. So the image is now ready, available, and tested. So the whole object of this practice was to containerize the Elegance application. As we can see, we have containerized the application and upload it to Docker Hub, where anybody can download it and run it in a computer.
Hello everyone, this is Ali and with me is Dino. So our part will be creating and testing a secure Swarm cluster. We will be building a secure Swarm cluster of 3 nodes. It will have 1 manager node and 2 worker nodes. Usually in production, it is good to have more manager node for high availability. The recommended number are 3, 5 or 7. But for this demonstration, we will just use 1 manager node and 2 worker nodes. Manager nodes handle all the configuration of the Swarm cluster and deploy the container on the worker nodes. So we will create 3 virtual machines: Docker 1, Docker 2, and Docker 3. Docker 1 will be our manager node. Docker 2 and 3 will be our worker nodes. These virtual machines are from our golden image, which is a blank installation of CentOS 7. So we will create 3 virtual machines. We will start with the first virtual machine, which is Docker 1. Furthermore, the host name has been set and it is a black image. So we will start by installing Docker engine on it. We will use the recommended way of installing Docker, which is using the Docker repository. We start by enabling the Docker Community Edition repository using the Young Config Manager. We will not be using the Enterprise Edition as it is a paid version, so we will use the standard Community Edition, which is enough for demonstration of this project. We are running Young Config Manager and we will be adding the repository to our Young configuration. Once this repository is enabled, we can now install Docker. After installing the Docker repository, we just have to run the yum install Docker. Currently, the latest version of Docker is 18.3, so this repository will give us the latest version of Docker, and installing Docker CE will install the latest Docker engine. You can see that Docker installation has been completed. Docker CE version 18.3 has been installed along with all of its dependencies. Now we are ready to use Docker. However, we need to keep in our mind that this has been done on Docker 1. For installing Docker, we will start by using the systemctl command. This will start the Docker engine. Once the Docker engine has been started, now we can initialize the Swarm cluster. Docker gives us a very handy tool to initialize the Swarm kit and all the underlying configuration required to start a Swarm cluster. We just have to run the command docker swarm in it and it initializes the cluster for us. Once the swarm is initialized, it gives us a token that can be used to join additional worker and manager nodes to this Swarm cluster. So for this part, the Docker engine has been initialized in a Swarm cluster mode, and we can now add more worker and manager to this cluster. A lot of work has been done in the background, but because of this abstraction, we are unable to see all the work that has been done that requires all the certification rotation, policies, report, mapping, and all the things that is required. This all has been integrated into this one simple command docker swarm init. So now swarm has been initialized, and we will now prepare Docker 2 and 3 so we can join them as a worker node to the cluster. If we run the Docker system info command on Docker 1, where we just initialize the swarm cluster, we can see that it shows swarm as active. It shows us the node ID, and it also shows us that it's a manager. Currently there is just one manager, and it is the only node in the cluster. We will see this will change as we add a new worker to this cluster. Now we are on the second node. This is also a CentOS 7 virtual machine created from the golden image that we used in the lab earlier. This is a blank installation, so we will start by installing Docker, and first step to install Docker is, as we described before, by enabling the Docker repository. So we will enable the Docker Community Edition repository using the yum config manager, as we have done before on Docker 1. Similarly, following the same structure, we will install Docker using the yum install docker CE. So the Docker engine has been installed successfully on Docker node 2. Now it is time to add this node as a worker node in our swarm cluster. Add the node 2 into the swarm cluster. We need to get the token to join a worker node in the cluster. To do that, we simply have to run our Docker swarm join token worker command on the manager node, which is Docker 1. So we go to Docker 1 and we run Docker swarm join token worker, and Docker engine will give us the token that is required to join a new worker node to the swarm cluster. We will copy this Docker swarm join command with the token and run it on Docker 2, which we just installed and started the Docker engine on. If you can see that we are using the same Docker join token to join node 2 to the swarm cluster, and once we run this command Docker acknowledges that this node has joined as a swarm worker node. So now our swarm cluster is having one manager and one worker. Just for the sake of demonstration, we will add one more node as a worker node. So in total, we will have one manager and two worker nodes. And now Dino will complete with the installation part of this project.
Myself is Dino. In the installation part, we are going to run the same setup on Docker node 3, which starts by enabling the Docker respiratory first. We will install Docker Community Edition. Then, now you can see the Docker engines that has been installed on node 3. Now we will start and enable the Docker service on this node. Systemctl will enable and start the Docker service, as this is automatically gets started by default once when virtual machine is rebooted. Obviously, it has to be done on all the nodes in the cluster. Once the Docker engine has been started, we can join this node to Swarm cluster using the same token, which we used earlier with the Docker node 2. So now you can see that we are joining the Docker node 3 to the Swarm cluster as our node using the same join token. So once when we run this command, Docker acknowledges that this node is a part of our worker node, and now we have 3 node Swarm clusters that we can use to deploy containers on it. Running Docker node ls shows us the nodes in the Swarm cluster. So if we run Docker node ls on the Docker node 1, which is the manager node, it shows all the 3 nodes that are there. It shows that the Docker 1 is the manager node and there is a star in front of the manager ID, and it also represents that this is the leader of the managers. Since we have only one manager, that same node is the leader. In case if we have multiple managers, Docker selects one as the leader and the other as followers. But we have a simple structure here with one manager node and 2 worker nodes, which are ready and active. Now we can use the Swarm cluster to deploy containerized applications. And if we run Docker system info, we can see that it shows us that Swarm is active and Docker node 1 is the manager, and shows there are 3 nodes in the cluster and 1 manager. And this is the overall architecture of a Docker Swarm cluster. In Docker system info, on the worker node also shows us the information about the engine of that node. For example, if we run Docker system info on the node 2, it shows that the Swarm mode is active. That means it is a part of its Swarm cluster. It shows the node ID and shows it's not a manager. This exactly represents the manager address to which the worker is connected. And now you can see the same on Docker node 3 also. Once our Swarm cluster is up and running with 1 manager and 2 worker nodes, you can just test our Swarm cluster by deploying service on it, where a service is a container that has more configurations involved. For example, we can run a container as a service with more than 1 replica. That is, when we run a container, it is just a single container, but we can run that same container as a service with multiple replicas. So here on node 1, the manager node, we are going to run our service by creating Docker service create in detached mode. We will name it test and assign 3 replicas so that it creates 3 containers of this image. We will use the same port 80 and run nginx where it is blank, and run nginx and it is a blank web server, and it should be enough to test our container Swarm cluster. So running this service gives us a message of that ID of that service, and now it will put the nginx image and starts deploying on its node. Docker service ls shows us the status of a service. As we can see that the name test and image nginx latest has been deployed with 3 replicas running on it. So now we should be able to test this. Docker Swarm has a very intelligent orchestration engine as it distributes the work accordingly on all the nodes. So if we run docker container ls, we can see that our replicas are evenly distributed on all the 3 nodes. If we run docker container ls, it will show us 1 replica of the nginx running on each of the nodes. As we deploy 3 replicas of our nginx image, Docker Swarm distributed 1 container to each node, so we can see that 1 container is running on each node. And by this you can see 1 container which is a replica of our test service running on node 2. And here there should be at least 1 container on node 3. And finally, as we use the port 80 in our service, we can now visit any of our node on the Swarm. It should now expose the port 80 of that node to this container going to Docker 1, Docker 2 and Docker 3. By this, it shows the welcome to nginx default page. This means that we can deploy any number of containers on this Swarm cluster, and Swarm cluster takes care of managing the deployment, lifecycle management and distribution of the containers. So our Swarm cluster is up and running. Now we can deploy containers on it. And now Kezer and Saeed will be continuing with the demo.
Hi, my name is Saeed, and I'm going to recap actually what we've done from the beginning until where we're starting again today. So initially we started with creating an application, basically a legacy application, and we've taken you through the deployment of that application as a standalone application. The second phase of that is we containerize the application, we put it in a Docker container. Once we completed that kind of work, and then we moved on to our other group where they've created basically a swarm. A swarm, basically, we're hoping that's going to be a cluster we'll be able to deploy our application. So in this phase right now, we're going to kind of tie up all the 3 phases together, and we're going to pull the application, the Docker container, and we're gonna deploy it to our swarm, and later on we will be able to show you how we can scale the application as well, and so on. So now we're gonna look at Docker, the services, and you will see actually that we don't have any services running right now. It's really clean. The containers, we don't have any containers. As you can see, it's very clear right now. So now we're going to create a Docker, the services, which is the legacy application we created earlier. And as we're creating this, we are also going to create a replica, and we are going to map the port 80 inside the container to the port 80 with the swarm, where you can expose it to the outside. And this is the username, the account, the Khizar, and the project name. So what's going to happen right now, as we enter, we have to wait a while to download the container, the app itself, and be deployed and built in our swarm. And as you can see, it created a new ID, a unique ID for the service. So now you can see a replica, one of one, within our swarm. And also you can see the application was deployed in Docker 1 in the local machine. So if we're gonna go and look at the application itself, you will see Docker 1, you'll see the applications deployed, and I think also if you go to Docker 2, it should be deployed, and Docker 3. So Docker 1, Docker 2, Docker 3 are the swarm that we created earlier, the cluster, and now we'll take you through the scaling of this application as well. So the idea is we're replicating the same application 3 times, and to make sure that what's going to happen in the background is the Docker swarm is going to orchestrate all that functions and going to deploy it automatically to the nodes that are available in our cluster. Now, if you go back and look at the service, and you will see now we have the service deployed in Docker 1, Docker 2, and Docker 3, and they're all running. In an enterprise version, I mean, if you have the multiple node, hundreds of nodes, and you can deploy this application to 3 nodes, then the Docker swarm will orchestrate and put them to whatever the nodes available that has enough memory or storage. Now we're also going to look at scaling to 6 nodes, and again, you can see how perfectly works, and we can check as well and see this application and which nodes are deployed. And as you can see, we have Docker 1, Docker 2, Docker 3, Docker 1, again Docker 2. So the application is deployed multiple times on the 3 nodes that we have in our swarm. And they're all working. So I think our experiment ends over here. And thank you very much.
Hello, my name is Khizr, and I will be doing the last demonstration of this project. As Saeed showed, that we were able to deploy the containerized application to the swarm cluster, and we were able to scale it up to 6 replicas. Depending on the hardware available, we can scale our application to as many replicas as we want, and the swarm will automatically and intelligently distribute the replicas on the nodes that it has. As we can see, currently we have 3 nodes and we have 6 replicas evenly distributed on the 3 nodes. I will now demonstrate how we can do CI/CD, continuous integration, continuous deployment, how we can update an image and deploy a new version of the image on the same swarm cluster. This is critical in enterprise environments where you have to deploy new revisions of the application very frequently. So the first thing we'll do is we will update our image. We'll make a change in the image and we will upload the change to our Docker Hub. For this, we will log into the virtual machine in which we first created our containerized application. So now we are in the machine, in the same virtual machine where we created our first image and uploaded to Docker Hub. We will go to the HTML folder where we have our Docker file. If we look at the Docker file, we can see the Docker file still exists and all the steps that we mentioned for creating the Docker image. So now I'm just going to run the Docker build command just to make sure and just to demonstrate that this is our latest image and there are no changes required. If I do that now, if I run the Docker build command with the same tag, username / the project name and the version latest, we will see that there are no changes. And if we push the same image back to Docker Hub, we will see that Docker recognizes that the digest is matching, and it will say that the version is updated, and it will say the layer already exists. And there will be no upload because there is no change, there are no changes uploaded yet as of now. So Docker reports that our image is up to date. And so we are in the current version without any changes. So what we're going to do now is we're going to make a modification to our application just to demonstrate how we can apply and how we can deploy new changes or new revision of our applications. So I'm just simply going to open the SQL dump that we created, and I will just change the title of our front web application. As we can see in this SQL dump, in this table, there is this title of our application or the blog name, NSA 713 final project, and we will apply a change. Demo version. So I have changed the title of the application. So now our application should be changed. I will now upload this image but with a new version tag. I will use a demo tag. Docker by default uses the latest tag, but this change that I'm applying, I can give it any tag, any arbitrary tag. So I'm giving it a demo tag. So Docker will now rebuild the image with a different version. So our image is now built. And now we can push this new version, the demo version, to our Docker Hub account. We will add, before when we were pushing the image, we were not using a image version tag. In that case, Docker assumed the latest tag. Now since we have applied a new change and we want to push that image as a demo version tag, we will do the same. We will mention the demo tag while pushing the image to Docker Hub. This time, Docker should see that there are changes, and it should see the sum of the layer changes. We can see that 3 layers were not changed, but there were 2 layers, actually 3 layers changed. So the Docker will only upload those new layers and give us our new version of our application. So our new image has been pushed to Docker Hub now with the demo tag, and the changes that we wanted to make are in this demo version. Now we don't need this virtual machine. We can actually power it off. So now we are back to our Swarm cluster where we have deployed the latest version of our application, which is running in this web browser as of now. Now what I'm going to do is I will instruct the Docker service to update my service with the new version, and I will say that in my update, instead of using the latest version, it should now deploy the demo version. I have to mention the service name. So now running this command will instruct Docker Swarm to update my service, which is already running with the image NSA 713 project latest version. It will update my service to move to the demo version. Docker by default updates the image one by one. So as Saeed deployed 6 replicas, we can now see that Docker Swarm will update our image, our service one by one. So currently it's preparing node 1, replica 1. So it has to now download the new image with the demo version tag from Docker Hub. If we go to Docker Hub, we can actually see that we now have a demo version available. This new version was tested a while ago. This is not required. So now this was updated 2 minutes ago. Now we have these version tags. Docker is currently running the latest version, and we have now instructed it to run the demo version. So as soon as it's prepared, okay, we can see that Docker has one of the container is updated, and it's now preparing the second node. If we open a new terminal while this is happening, and we SSH it into Docker 1, and we do Docker service PS test. Sorry. We can see that the node 1, the first replica, has been updated to demo version. It's no longer the latest version. It's the new version that we instructed Docker to update to. Other versions are still running latest. Docker is now orchestrating the whole process of updating this CI/CD pipeline, where we can apply changes automatically as they are pushed. If we run this again, we should be able to see that more replicas are now in demo version. We can see that there are at least 3, 1, 2, 3, and 4. So what Docker is doing is it's shutting down the old Docker images, and it's creating new containers with our required version. And this is done without any downtime, because Docker, if we now visit our Docker, we can see that our application is on the demo version. This is the change we did in the MySQL database. And we can go to any node, and we can any of the 3 nodes, and we should always land on the demo version, because this is the current state of our service. So now if we run Docker, here we can see the Docker has updated our service on all 6 replicas. And if we run Docker, if we check, now all of our replicas are running in the demo version. The latest version have been shut down. Now, as we see, it was just a simple update service command for our application to move to a different version. We can as simply as this roll back. I will demonstrate how we can roll back our changes that we applied. So let's suppose the changes that we applied on our service were not desirable, or we want to roll back for any reason. We can simply run Docker service rollback, and Docker will take care of this. Docker intelligently knows that what changes were applied in the last update, and it will roll back those changes. So Docker will now roll back the changes that we applied on all 6 replicas. It will take a few seconds. Docker is doing this step by step on one replica at a time to avoid any disruption of the service. So now all 6 of our replicas have been rolled back to the previous version. So if we now visit our Docker port 80 service, we should see that we are back on the original NSA 713 final project without a demo version tag in the title. And we can go to any node, and we should see that we are on the current version. So this is how we can apply rolling updates, and we can do blue-green deployments. In terms of blue-green deployments, we can deploy a new version on a different port. So instead of creating a service, we can create a service on port 81 and deploy a demo version on port 81 and test it on port 81 and then move this service to production. This can also be done. This is the whole idea of blue-green deployment, that we deploy a new service on a different port, on a different service name, and once our application has been tested, we can then move it to production. That's it. Our Swarm cluster is up and running. We can play with the number of replicas that we have. For example, we can update our service, and we can ask Docker Swarm cluster to reduce the number of replicas to 3, and it will just kill 3 nodes, 3 replicas, 3 containers, and we will be down to 3 containers. And as you can see now, if we do a Docker service PS of our test service, we should see that only 3 containers are running and all others are shut down. Let me grab this. So we can see that only 3 services or containers are running, and all 3 of them are distributed evenly on the 3 nodes that we have. So this was the complete demonstration. We went from creating a legacy application that was a standard WordPress application. Then we containerized the application by writing a Docker file. We created a Swarm cluster, and then we used this Swarm cluster to deploy our containerized application. We can apply changes. We can create a CI/CD pipeline. We can apply rolling updates. We can do blue-green deployments on the Swarm cluster very easily without disrupting. And Docker Swarm cluster handles most of the orchestration and automation behind the changes that we need, behind the revisions that we need to deploy. That's it for the project. Any questions?